You muted, but can you try it on your side? Oh, all right, there you go. That works. Do you use a Mac by any chance?
Sorry?
Do you use a Mac by any chance?
The map?
Like, do you use a Mac or a Windows?
Yes, I use map. I use map.
Let me try to do this with the browser, I guess.
Well, if you cannot share, I can help you with the screen sharing.
I'm trying. It's all right. All right, so I guess I can share a window, but not.
I think it works now.
All right, I think I can do a window. I think a window is fine. All right. Stop sharing. Okay, cool. I think this works. I will be back like a couple minutes before it starts.
Yeah. Yes.
Oh, sorry, I was turned off the sound if you said something.
Yes.
All right, cool. I'll see you in a bit then.
Bạn có thể báo nhỏ nhạc với mình một chút xíu được. Nhạc nhạc. Ok. Mình cảm ơn.
Easy for you guys.
Hello, everyone. I think people are getting into the room, so can we wait a few minutes for others to join? Hello, everyone. We will start in 2 minutes. Uh, Hello, Nam. Are you there? Are you ready?
Can you hear me right?
Yes.
Cool, cool. Is it getting busy for you guys?
Yes. Super
I can
busy.
imagine. Yeah,
It's super chaotic here with all the logistics things.
hmm it's not easy for sure.
Yes. Well, we could because it is the first time we bring together like that many global resources to Vietnam,
hmm
and so that's why, like, you know, beyond our widest expectation to organize this event with that much support from different stakeholders. So
Yep.
that's why we have to try our best to bring, to bring the best to the attendees and to make sure that everyone is happy with the event, not only in the event but also before and after it.
hmm
Yes. So when do you come to Vietnam?
I'm arriving Thursday night.
Oh, I'm sorry if my it's quite like a little noisy from my side
Oh,
because
good.
today I have to like go outside to work. Side checking. I'm side checking at the event, so I have to.
Nice, nice, nice.
Yes, I have to be in a coffee shop.
Yeah, I'm flying in on Thursday night. It's gonna be a pretty far flight from New York.
Yeah. Well, actually, if I think because we have the Discord channel for Hyperlane, so maybe we'll have some questions from the Build-a-thon team there. So please assign a PIC from your team to answer the questions, if any. Okay, I think we're gonna start now.
Cool. Sounds good. Do you want to say a few words or should I just get started?
Yes, sure. Okay, hello everyone. My name is Ling, and I come from Eat Vietnam team, and welcome you all to the workshop today with Mr. Nam from Hyperlane. He's the co-founder of Hyperlane, and he's giving one bounty in our Build-a-thon 2022 this year. And so, welcome Nam to the workshop. And I would like usually like in the workshop I would briefly introduce a little bit about East Vietnam and Billathon also. But I think because we have done a series of workshops already, so the Billathon teams and also the audience are quite familiar with the event and also the Billathon format. So I think that they would love to jump right into the main topic of today's workshop, and I would be very happy if now you can share again about your bounty because we are moving very close to the submission deadline of the Billathon. So I think that all the Billathon teams are very curious about your bounty because you came like later compared to other sponsors. So maybe they will need like more info from you. Yes, so I think I will hand over it to you, and you can start your session now.
Thank you. Yeah, as I introduced, my name's Nam. I'm one of the founders of Hyperlane. We're very excited to come to Vietnam to, yeah, I think kind of meet the community in Vietnam and see kind of like what the reputation is like. Um, One of the things that we do a lot of these. I think we've done like we just came from EFSF. We did Bogota in Colombia. We have done ETH Berlin. So we go to pretty much every of these events, and the reason why we go is because we really want to meet builders like yourselves. I think that I'll introduce Hyperlane in a second, but for us as a protocol, as a developer protocol, it is super critical to have, I think, imaginative and creative developers build what we consider to be the next generation of applications in our space. And so maybe let me start with basically telling you a little bit about Hyperlane. So let's see if all right, I think everyone can see my screen. So yes, as I said, Hyperlane is a developer platform for enabling interchain applications. And so at the base level, this basically means is that like we have APIs in smart contracts on multiple chains that basically allow a smart contract on chain A to send a message like arbitrary bytes to another smart contract on chain B. And so the question you should definitely ask yourself is like, why would I care? And the reason why you care is that like today, when you build your applications, right, like in this what we call single chain context, you have to choose a blockchain, right? You can't choose many blockchains, and that choice of blockchain has pretty significant ramifications for the trajectory of your project. So first of all, developer experience, right? Like most of you probably have used Solidity or like the EVM because there's a lot of tooling available. But you know, if you go to other blockchains, that's maybe like less so. User experience, right? Again, like your choice of blockchain basically determines like what is it going to be like for your user to use your application, like what wallets are available, what infrastructure is available. Separately, even like zooming out from that, there's platform risk. So if let's say you use some kind of blockchain because you thought like, oh, they might be up and coming, but then it turns out like no one cares, right? Or maybe like the kind of security parameters of the blockchain did not pan out as maybe the core developers planned them to. Now you're kind of susceptible to kind of like all kinds of security risks. And then probably the most important is ultimately the network effects, right? Like usually you choose a blockchain because you think like, oh, there's a lot of users here, or there's a lot of like these other projects, or there's liquidity, or there's all these kind of things that really like make up like the value of a choice of blockchain that I think as a developer it can be hard to kind of figure out. And like ultimately, right, like we kind of like build these applications because we think they want to be like super decentralized and be able to kind of like compose with other protocols and other applications on these blockchains. But I think in the world that we live in today, where there's a lot of different blockchains and those can't natively talk to each other, that kind of composability is like very significant, like significantly limited, basically. And so when today most applications, when they say they're going cross-chain, right, because they realize that they don't want to be constrained to a like single environment like this, really what it means is you just deploy another app on another chain, right? So I think like you have plenty of examples like Sushi, Aave, like all these big kind of products. Really what they're doing is they're just deploying another instance of their application on another chain. But those don't talk to each other at all. And so basically the state of each of these applications or instances of smart contracts is totally separate, right? So we call them like islands, basically in a sea of oceans, where like they can't like have ships go in between them, right? And so let's say when you trade on Sushi on Ethereum, like you don't actually get to use any of the liquidity that's available, let's say on Polygon. And so sometimes even this becomes parasitic because then let's say if you deploy Sushi on like a new chain and you incentivize liquidity there, what could actually happen is you like move like liquidity out of your application from let's say Ethereum into Polygon, and so it's basically a zero sum game, I guess, in some effects. And so yeah, so we think obviously that's a pretty shitty experience. Like we think that crypto can't really kind of fulfill its vision if that's the situation we're going to be in, both for developers because they have to kind of think about this like choice of blockchain, but also for users because if you think about it, like your choice of blockchain, basically what you're saying to users who are not on a blockchain is like, look, I don't care about you. You have to figure out how to come to us. And I think we've learned over the last kind of like 2 decades of building digital products that one of the most important things to do is to make it easy for users to use your applications, right? Like anything that can reduce the friction of users using the application, you got to do. And so Hyperlane is basically kind of a way for you to build what we call interchain applications, where you can actually deploy smart contracts in every chain, but they're like part of a logically same application. And so you can effectively reach users on all the chains that Hyperlane supports. You can support all the liquidity that on all those chains. And so you will have a much more seamless experience for your users. And so what is Hyperlane itself? It's not actually another blockchain. It's a network between existing blockchains. And so there's no kind of like another node that you have to run or anything. You just use the existing blockchains that you're all kind of familiar with. And so with that kind of what we call intra-app communication, right, between the smart contracts of your application, we basically enable interchain composability because applications, protocols, users can interact with your protocol from wherever they happen to be. And so you kind of like avoid what we call ultimately the existential risk of having to choose a single chain. Like I've personally been in this industry for about 4 or 5 years now, and like I've seen basically like regret basically of people who kind of like choosing the quote unquote wrong blockchain. Or then I have to figure out how to move it, and obviously that's like just painful. And so I hope you have a bunch of builders here in the audience, because basically what I'm going to do is just basically do a live demo of, I think, how easy our API is. And our API really has like kind of 4 sub APIs. So at the core level, Hyperlane, as I said, is a messaging protocol that allows a smart contract to send a message. And so let's maybe start with that one. So the interface is very simple, right? So basically on the sending chain, there's a contract we call the outbox. And on that outbox, you basically specify 3 parameters, like the destination chain, which is just like basically equivalent of a chain ID. The recipient, which is just the address of the smart contract on the receiving chain. It is in bytes 32 instead of address because we plan to support non-EVM chains as well, which don't have 20 bytes as like addresses basically, but like 32 bytes. And so in our case, addresses are always going to be bytes 32. And then the message, which is just like arbitrary data. And on the receiving side, you basically have to kind of implement this handle interface, which allows smart contracts to accept these bytes, right? And so basically, your recipient will get called with these 3 parameters: the origin, which is just again the chain ID of the origin chain, not the sending chain; the sender, which is the address that sent the message on that sending chain; and then the message, right? So pretty simple interface. And so let's get into the demo. So let me share my different window. Actually, I should probably just move this in here and then share different window. Okay, I think this shows. All right, so basically you can go to our docs.hyperlane.xyz. And here on the left side, we have kind of those like 4 APIs, as I mentioned. And I'm basically just going to go through the quick start tutorial to show you kind of how easy it actually is. And so basically to start, we can do this all in MetaMask, is that we have to go to the outbox contract on kind of the respective like block explorer. And again, this is just an example as how to interact with them, because we use MetaMask for it to be simple, but obviously you can do this inside your smart contracts. But so on this list, you can find kind of all the like outbox contracts basically on whatever chain you're on. So like in this case, I have the one on the Avalanche testnet. And you can basically, let me actually just refresh this. So here, right, you can just connect to your MetaMask. And then you can call functions on this contract. And so, like I mentioned, the dispatch has like 3 arguments: destination domain, recipient address, and message body. And again, we help you do this on the docs page. So first, on a destination domain, we have another page here, which is basically all the identifiers, right? So in our next version that we'll hopefully deploy in December, these will actually just be equivalent to the chain ID. But for now, they're kind of these separate IDs. So let's just send it from basically, right, Avalanche Fuji network to the Girly testnet. So the domain identifier for Girly is 5. So we just put in 5. We put in the recipient address. So in this case, right, it could be any recipient basically that you'd want. We've pre-deployed these test recipients whose source code I'll show you in a second. But it's basically this is the address of it. And then again, because it's bytes 32, like 32 bytes for an address instead of 20 bytes, we have to kind of zero pad it with like these 20 bytes, 12 bytes of zeros. So you can just copy this. You can add the recipient address here, and then the bytes. And right, you can select whatever message you want. And so you just have to turn them into bytes. And so we can just use kind of any string you want. So we can do something like hello from Eve Vietnam workshop. And then this is the hex string. So we can just copy this and paste that into here. Remember to prefix the 0x. And then that's it. So we can send a message. Just confirm the transaction has been sent. It'll probably take a second. There you go. All right, it's included. So one thing we also offer is the equivalent of basically like a cross-chain block explorer or message explorer. So if you just go to Hyperlane, explore at hyperlane.xyz, you will find kind of like all the messages that basically are going through the Hyperlane system right now. And so you can see here, this is our like Fuji to Girly message. You can also just take the transaction hash and then paste it in here, and then it will show you the message as well. And so you can kind of see like here, this is a message going from Fuji to Girly, right? This was the original transaction hash. Basically, what happens when you send a message over to Hyperlane, the transaction has to get finalized, right? Like basically depending on the origin chain, like finality properties, you have to wait for finalization. So Fuji is pretty fast, 6 seconds. Validators will basically then sign the message effectively. I mean, I can go more into detail if people are interested, but basically the message gets signed and then gets relayed over. And so you can actually see that the transaction hash on the destination here on Girly is here. So we can just open it up in the block explorer. And then, oh wait, was it just hello world? Oh, that is weird. I'm actually going to check it like later. But you can basically see how we send a message here. And if you look at the recipient, in here, right, we said like this was the recipient, so we can just see what the recipient actually did with the message. So here in the contract, we go to the here's the handoff function, right? So basically it receives these 3 arguments, and all it does is it emits an event with the data. So let's say here, last sender and last data. And so if we read the contract, we can see here that this is the last sender, which is like my address on Fuji. And then last data is here as well. And that's actually the bytes that we sent, if you remembered. So yeah, so that was right. Like that was it. So that's how we send a message from Fuji Avalanche Fuji to Ethereum Girly testnet. And so hopefully, as I showed you, that was very simple, but I think we can do better than that. Because if you think about it, like one of the things that you have to basically do is to implement smart contracts on both sides, right? So both sending side and destination side. And as we've talked to developers like yourselves at kind of the various events over the year, we've realized that sometimes like the use cases that developers have, or like that you guys have, doesn't actually need a smart contract on the destination chain. Like often, like very common kind of I guess patterns when it comes to like just writing smart contracts in general is that you basically want to permission, let's say, a smart contract to be able to do something and basically like call another smart contract. And so I think a typical example would be, for example, governance, right? So when this is actually a use case that we're talking about right now with Uniswap, but let's say Uniswap has contracts on all different chains, but they have the DAO on Ethereum. And so really what they want to be able to do, right, is to basically allow the DAO on Ethereum to like own contracts on another chain. But like, what does ownership mean? Ownership basically means the ability to like affect change, and only the owner being able to do that. And so, right, like what say Uniswap could do is they could just deploy like smart contracts and use the messaging API on all these different contracts where they have like a handle function, and then like that contract basically acts as the owner on a different chain. But we can just abstract this into what we call interchain accounts, basically where you can kind of create these proxy contracts on a remote chain for a given origin sender account on an origin chain. And so that basically allows developers to not even have to deploy anything on a remote chain. And we use basically this like opcode card crate 2, which is like really cool and basically allows you to even like have predictable addresses for these interchain accounts, these proxy contracts, without them actually being deployed. And so the interface is basically, again, very simple. You have kind of a dispatch, right, where you basically like have a destination chain again, a recipient and data. But like really like receiving is like, there's no smart contract you have to write on a destination chain. And so really what you end up doing is that the kind of the child or like the oni on destination chain just computes the interchain account address and then sets that to be, let's say, the owner of itself. And so again, let's take an example on our docs page right here. We have the accounts API quick start. And so basically what we have to do is we have to navigate to the router of interchain accounts. And so that ends up being this address here. And we do basically just like we kind of ABI encode these function calls and just like send them along. And then our proxy account on the destination chain is able to do these function calls. And so all we have to specify is basically the domain, which again, we'll just send it to girly, and then these calls. And so let me break down a little bit more what that is. So basically these calls are an array of like call structs. And these call structs are basically two things, right? Like the address, like that the interchain account is supposed to call, and then the call data, which is basically the ABI encoded function call. And so again, we're just going to be calling the test recipients that we have deployed in every chain. So the recipient is just this address, and then our function is just like, if you remember, actually let's open here. There's like basically just like a random function that we call like foobar here, with like some amount and some message. And so in our docs, we can like show you just like an example of like how to generate that. If you've built a smart contract, you know how ABI encoding works. But basically, this is kind of the tuple, right? Like the recipient and then the call data of the ABI encoded function call. And so we can again copy this and paste that into here. We can send a message with MetaMask. So let me send it. I guess you don't see the MetaMask window for me, but the transaction succeeded. Once again, we can look at the Hyperlane Explorer. We can see the ICA message here. It's also nice is that we can show you that it's an ICA message, and we will actually decode that function call here, right? So like you can see here, the ICA call basically has it has an array of like one call. This is a destination, and these are the raw bytes that we'll do to that recipient. And then again, we just have to wait for the transaction to be included on the destination. Let's refresh. Should be there in 1 second. I think Curly lately has gone through some congestion, so it's been taking a little longer to send it early. Maybe actually I should just send it to somewhere else. Like I said, we can send it to any supported chain. So I guess we could just send it to, let's send it to BSC testnet actually. So just all we have to do is change the destination domain. You can send another message. And then again, we will see the message pop up here in 1 second. There it is. And I think BSC testnet has been not as congested as Curly. But I guess we could just keep both open and see who comes first. Oh, all right, so Curly succeeded. So here on the block explorer, we can once again see the transaction. We can see the logs here, hello world from an ICA. And here actually in internal transactions for the silly developers out there, you can kind of see that like this is kind of the call that we've made, right? Like this is our Interchain account basically, and this is the call that we've made. And so again, like we basically are able to affect change on the destination chain without even having to have any destination chain contracts, which are like Hyperlane specific destination contracts, which we think is pretty cool. And I guess for good measure, we can just like show you the transaction here on BSC testnet as well. Right, and so that's another cool kind of like example, I think, of using Hyperlane. Again, all you have to do is call a smart contract on the origin chain, and you can do kind of like arbitrary things basically on the destination chain with the proxy account, like the Interchain account, for the caller on the origin chain. All right, next, I guess use case that we found as we've talked to more people is that sometimes what you actually want is you have, let's say, a smart contract on, let's say, Polygon, but you actually want to know something about the state on Ethereum, right? And so this is, again, effectively the Oracle problem. And think about, let's say, like if you have a lending market on Polygon, but you want to know the price of a particular asset, and that Oracle just happens to only exist on Ethereum, right? And so one thing you can basically do is you can, again, like if you just use the like very plain messaging API, you could send a deploy contract on both chains and send a message, and then that contract on Ethereum makes the read to the smart contract to the Oracle, let's say the Uniswap swap, and then sends a message back to Polygon with the result. And so again, we've kind of abstracted it away for developers where they can just use a very simple Interchain queries API to do that. And so basically what you end up doing is you specify, again, destination domain, you specify the call, which is right the view call that you want to make on the remote chain, and then you specify a callback, which basically will be called from the query router on your contract with the result of that view call. And so again, you don't have to deploy anything on the remote chain. Like another example is ENS, right? Let's say like the ENS registry is on Ethereum, but like you want to use it on, I don't know, like Celo, let's say. Like all you have to do is kind of basically construct this call and then call the query router with your query. And so we can again go to our quick start to kind of show how that would work. So on the queries API, we basically deployed this kind of like query sender on each chain, which would be on the origin. And you can basically kind of do a query address, and basically all we really do is we have like this like handle query address result function that basically just like takes the result and like emits it out. And so let's go to the query sender on Fuji again, right? And so let's call query address. We send it to some domain. Let's do it girly again. The target, let's say in this particular case, in the quick start, basically what we want to do is we want to query the owner address of a particular contract. And so basically the target is that contract. So in this case, I think it's like the sum of our contracts here, but you can add whatever you want, any contract you want, and then just the API encoded like function call again, which for owner ends up being this. And so basically if you, again, send this transaction, and then we look at the Explorer again, it will show up in 1 second. All right, there it is. And so this is an interesting one because there's basically two messages, right? Like first, there's the message that sends the query from Fuji to Girly. And then that message, when it gets processed, will basically make a view call on Girly. And then that function call will actually send another message back to Fuji. And so kind of whenever this is done, this will basically be two things. So let's see, whenever that goes through. I guess, like I said, Girly is a little congested, so just for good measure, we can again send it to BSC testnet if we want to by right here. All right. Always happens, huh? Whenever I want to do this. So yeah, so basically if you look at a transaction here, that's kind of the view call that happens. So again, an internal transaction. So we can basically see that here FFD1 is the kind of like function that we make. In the logs, you can see that basically we return the query with the owner here. And so actually, if we take this transaction hash, it will show up twice in this list, right? Because it's both the like processing transaction from Fuji to Girly, but also the sending transaction from Girly to Fuji. And so we can see this is already completed. And so on the block explorer here, we can see that the query was resolved with the owner of the address right here, right? Coming from Girly. So yeah, so that's again as simple as how you can basically make queries to other chains with just a very simple API. I can show you how it looks like, right? I just like call query of the destination main, the call, and then the function on your contract that handles the callback. And then last but not least, sometimes you want to move value, right? Let's say like a typical example that we hear often is that at hackathons that someone wants to make some kind of like a yield farm manager where like you have some assets on some one chain, and then that those can basically productively kind of like put to use on all the different chains wherever the yield happens to be. And so for that, you need to be able to actually move value, right? Like a lot of bridges are built on something like Hyperlane. And really what you end up doing is you put the tokens in a smart contract, you send a message over to a destination chain, and then you just issue basically a derivative and synthetic, like wrapped USDC or something like that. And it's really the only reason why it has value is because it allows like holders of that asset are able to kind of like deposit that back in that smart contract. Like the synthetic gets burned, and then the collateral on the origin chain again gets unlocked. And so we think there's going to be a lot of different ways of sending value. and we kind of like don't have like a single one, but really like we want to allow developers again to use the best available mechanism to do so. And so we have this what we call token bridge API, which kind of like abstracts basically multiple different value bridges, as we call them. And so the first thing that we have supported is the recently announced USDC bridge by Circle, the asset issuer, right? Because instead of, again, you locking and then minting wrapped USDC on another chain, with Circle, you actually natively burn USDC on the origin chain and then mint native USDC on the destination chain. And so the interface is very similar to kind of the messaging API, right? So again, you send to destination chain, to recipient, you have a message, but then you also show which token you want to send, what's the amount, and then what bridge you want to use, right? And so in this case, the bridge is Circle. And on the destination chain, you have a similar equivalent to handle, where you have the origin domain, you have the sender of the tokens on the origin chain, the message, but then also the kind of like the token, like right, like the USDC address, let's say, on the destination chain and the amount. And let's once again do a just run through the quick start. And so first you have to get some USDC, right? So you can get USDC on the USDC faucet. It's currently on testnet, it's only supported between Girly and Fuji. And so the first thing you have to do is approve the token bridge router with the USDC, right? Like any kind of like token interaction, like a normal ERC20 interaction. And then you can, once you have that, you can call dispatch of tokens, right? And so let's connect our MetaMask here. And then dispatch of tokens, we send 0 ethers, we send to Fuji, which is this domain ID, to a recipient. So we have a special like again, anyone, it could be anyone, but we have a like test token recipient that you can use. So we do this right here. The message body is, we can again send whatever. So actually let's just send what we had here. The token. So on Girly, the token address, what is it? Oh yeah, here. Amount, let's just send like, there's 6 decimals in USDC, I think. So let's just send like 1 USDC, which is I think this, I want to say. Should just send 1 less. And then the name of the bridge. So in this case, it's just Circle. And if we send that transaction, ooh, I'm not able to estimate gas, which means that I've done something wrong here. Oh, maybe I've not approved enough. Don't think I know right now why. The estimate gas is about to fail, so I'm not sure why. I guess I'll have to. I definitely did this the other day here. Let's see what I used. Yeah, all right. I might just not do this right now, but if interested, you should definitely be able to run for the quick start later. And like you can see here as an example, basically the USDC gets burned to the 0x0 address. And then if we look at the Explorer, Circle. Oh, that's why. All right, I'll fix this later if you want to, but if you want to check it out, and I'll be available on Discord. But yeah, that's how you would send the interface. You can see was hopefully pretty simple. Yeah, so I think those are basically the APIs that we have available, and yeah, we would be very excited to see folks like yourself kind of like try out Hyperlane and kind of build again what we call the next generation of applications on protocols which are just natively interchain. We have 4 bounties at eVietnam that we are very happy to see folks be able to get. So one is 2K for just best overall use of Hyperlane. That just kind of is whatever pretty much we think is like uniquely taking advantage of Hyperlane in a way that's building kind of new experiences. We have a 1K bounty for best use of Hyperlane in a kind of DeFi setting, right? So if you build like a cross-chain lending market, cross-chain swap, anything kind of DeFi where like you allow people to basically interact from whatever chain they happen to be on, like that's 1K there. We have 1K for best use of NFTs, right? So what you can imagine with NFTs is you could have like cross-chain NFTs, you could mint on one chain, but like actually use them on another. You could have NFTs that kind of have different properties depending on which chain they're on. You are able to like collaborate with different projects on different chains. And then last but not least, we have a 1K bounty for best infrastructure use of Hyperlane. Because again, we've done some of that work, but we think that like there's a lot of more interesting infrastructure that you can build to allow developers and users to kind of like basically come into this what we call app-based interoperability period, versus forcing users to kind of use these bridges. And so yeah, there's 1K bounty for that to kind of like think about like what's the best infrastructure for this kind of cross-chain world. And I think that's mostly it. I know I went through a lot, and there are, I think, some people that came in later. So I'm very happy to take the remaining time to answer any questions that anyone might have.
Thank you, Nam, for your very insightful session. I think I will receive a few questions here. So the first one is that can you mention some benefits if I deploy on Hyperlane?
Yes. So maybe coming back to the original point here is that, so first of all, Hyperlane is not a blockchain, right? Like you don't like kind of like, right, like deploy your contracts to Hyperlane, but really like you deploy your smart contracts on all the different chains that we support. So we currently support 8 chains. That is Ethereum, Polygon, Arbitrum, Optimism, BSC, Avalanche C Chain, Celo, Moonbeam. And so you deploy your contracts on these blockchains, right? There's nothing like kind of like new, like different, I guess, about deploying. And again, the precise reason why we think like that's kind of like a funny question basically is because it's so weird that like deploying on a chain kind of determines so much of your kind of fate, right? Like in the Web 2 world, it doesn't matter if you deploy to GCP or AWS, like your users can still use you. But if you deploy on like Polygon versus BSC versus like Celo, right? Like the choices of where you deploy has a huge impact on your application. And so I think the main benefit that you get by deploying on Hyperlane is that your application becomes accessible from everywhere, right? So if you have users on Polygon, on BSC, on Ethereum, like those users can just use you instead of having to figure out, like, let's say, right, like you have a Polygon application, but there's a bunch of users on Avalanche, like they can't use your application, right? Like they have to figure out how do I move, like, let's say, AVAX from Avalanche over to Matic on Polygon. And they have to use some bridges, and obviously there's a lot of kind of hacks of bridges. And so I think there's just a lot of anxiety about for users to like figure out how to use your application, and that ultimately means that less users and less liquidity can use your application. And so we think that application developers should basically kind of internalize basically that cost by like basically building interoperability natively into the application. And that is what we consider basically like better applications. And we think that, you know, there will be many more blockchains going forward, and users don't care, right? Like users don't really care which blockchain you're on. They just want to use your application. And so the benefit ultimately is to allow users to use your application in a way that like today they won't be able to if you just deploy on a single chain. Cool. I don't know if there's any other questions. I haven't seen any in the Discord.
Yes. Well, I think that maybe, yeah. Well, I think it's not really a technical one, but we had received another questions. Like, why do you decide to join the Billathon bounties? Like later on, not in the beginning, because
Yeah, it's just we saw it a little later. We didn't know about eVietnam until very recently. So that's certainly unfortunate. We also expect like most kind of like event hackathons like this are like quote unquote like right like hackathons in the original definition of the word, which are like a weekend where you build. And I guess the buildathon is different in a sense that it's not actually like not like a hackathon, but just like a time period during which you build a project. And so yeah, unfortunately, we have come a little late, but we still hope that we have again hackathon or not, we hope that we have a compelling offering for people to kind of build, I think, compelling applications. I see another question, which
yeah,
is about the different chain securities affected Interchain app development. Yes, right. Like I mentioned, you like obviously like different chains have different properties and different trade-offs, and like the kind of the key part that we were saying is that like you want to avoid users having to think about this, but you as a developer really want to be taking on kind of that determination. And so messages ultimately, when they're sent from one chain to another, right, like the destination chain has to kind of both basically like trust the message as well the state that it's coming from. Like the interchain I guess technical problem effectively is the Oracle problem, except that the like source of the Oracle information is just another blockchain. And so you're subject to basically right like the same kind of questions about the validity of state on the origin chain. And so you certainly don't want right like to like read significant state on a chain that could technically reorg on you. And there's right like proof of work, proof of stake that kind of secures that state. But it's definitely something that you have to think about, and it's something that is definitely like I would admit more complex than a single chain context. I think that being said, we haven't seen, as far as I can tell, like any like basically safety violation of like blockchains, right? Like the closest thing are basically like very deep reorgs of chains where the proof of work budget is not that large. But for proof of stake chains, I haven't seen kind of like an actual like uh, I guess fork effectively, or malicious fork at least. And I'm very happy to kind of go into more details if you're interested. Like David asks, yes, I will be at eVietnam. I'm getting it on Thursday night. I'll be there Friday. Very happy to get feedback in person. Also, we have our Discord. We'll be on the Discord channel. You can message me on Telegram or Twitter. Um, and yeah, very happy to kind of answer any more questions, basically. Interchains among different blockchains. Yeah, so as I said, we support 8 chains today, right? So that's Ethereum, Polygon, Arbitrum, Optimism, Avalanche Seed Chain, BSC, Moonbeam, and Celo. And we will like be expanding that rapidly. Like our view is that basically there will be many, many blockchains. And so we want Hyperlane to be the connective tissue between all of these blockchains. And so if you have any particular requests for new blockchains, again, feel free to join our Discord and share them there. But yeah, like the goal is for sure for Hyperlane to be everywhere.
yeah. I just want to add like an info for the previous question that you can still constantly ask questions in Discord channels of Hyperlane. And we and it's in Discord server of Hyperlane in East Vietnam. So please feel free to reach out there. I think Nam, please like be, be present at Discord
Mm-hmm.
server to answer the questions.
Yep, yep. Cool. Yeah, any other questions that folks might have?
Okay, and we received another questions. What are the criteria for selecting the winning team of Hyperlane Pound Bounty?
Yes. So ultimately, right, like I mentioned, we go to a lot of these, and what our goal is to just see people building interesting things on top of Hyperlane. And so I think what we want to like the criteria, I guess, are ultimately like yeah, original applications that we think like make use of Hyperlane in a unique way. And we do want people to actually uh, build something, right? Like kind of like there needs to be a credible path to basically seeing how this would be built. But it doesn't have to be like super polished or anything. Like I think just kind of showing kind of like the critical bits and pieces about how this will work or how this would work is fine. But we do want to see kind of like yeah, like I guess specific prototypes. Ryan, you asked if we'll have any more events. I'll be in Vietnam. We will mostly, I think, be around the conference. If you are going to ETH India, we'll also be in ETH India the following week. Maybe we will be at Taipei Blockchain Week as well. But if not, definitely if you're looking for, yeah, what kind of events we have, follow our Twitter. That's probably the best way of keeping in touch.
Well, another questions. Will you guys hold any future events? Like you mean organizing, right?
I think that's what I just mentioned, right? Like, yeah, we will be at the conference. We don't have like any specific side events, if that's maybe what the question is. We will have one again at ETH India, but at ETH Vietnam will mostly be around the conference.
Yeah, sure. So we hope that we will have like we can host another Hyperlane workshops or gathering soon in the future.
That's true. Yep. Yes, and there is a in-person workshop that I will do on Friday at 3 p.m. I think.
Yes. So do you have any other questions, guys? Well, I think that's maybe that's all for today. We don't really receive any other questions. So
Hmm.
I think do you have any other thing to share now, or you have any other special advice for the Bilathon teams before submitting the projects?
No, I would definitely say like don't be shy about reaching out. I think sponsors like ourselves always appreciate people who are putting thought into things and who are generally trying. So yeah, definitely wouldn't be shy about that. But otherwise, yeah, happy to meet folks on Friday. And yeah, good luck building.
Yeah. So well, I really hope to see all of you in the event, and we only have a few days left until the event. So we are put together a lot of effort. So we hope everything will pay off in the event. And Nam, hope to see you soon in Ho Chi Minh City. And please reach out to us if you need any assistance from our side.
Yep, will do. All right,
Yes, so
bye.
thank you so much, guys. Thank you for today. Bye bye.